This is Josh White with JW Math Tutoring. In today's video, I'm going to go through Bluebook PSAT 10 Practice Test Number 1, Module 1. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Before I get started going through these problems from Bluebook PSAT Grade 10 Practice Test Number 1, Module 1, I just want to mention a couple things. First, if you like this video, of course, please do give it a thumbs up, subscribe to the channel, and sign up for notifications. Second, this video may run past the normal allotted time of 35 minutes per module, and that's only because some of the problems I will show multiple methods to solve them, including using Desmos. And then lastly, do check out the videos to the other modules from the same practice test, Module 2A, the easier of second modules, and Module 2B, the harder of the 2 second modules. So let's go ahead and get started then. First question up here just wants to know, what is the x-intercept of this graph shown? Well, we can clearly see it is intersecting the x-axis, here at 4, 0. So the correct answer for this problem is just going to be letter D, and we can move on. All right, so here we have a relatively straightforward question where they give you a value of x, and they want to know what x plus 6 is equal to. So if x is 40, what is x plus 6? Well, it's just 40 plus 6. That's just going to be equal to 46. So correct answer for this one is just going to be letter C. Next, question number 3. Here we have a basic percentage question. So there's 840 seats in this auditorium. Students occupied 50% of them. How many seats students occupy? Well, this is just asking for 50% of 840. So if we just go to Desmos, you can literally just type it in, 50% of 840. And that gives you your answer, 420. Correct answer is C. We can move on to the next question. Next up, question number 4. Here you are adding two like terms. So it's just 50x squared plus 5x squared. Well, we combine the coefficients in the front to make 55. The variables stay the same. So the correct answer is letter D, 55x squared. However, I will show you that you can also do this in Desmos, and it's probably not really useful for this particular problem, but the general concept of matching equivalent expressions is something you will use a lot. So here is the first expression. Now you would go through the answer choices, and you would see which one of these overlaps it completely. Now I'm going to zoom in because the numbers are so large. So notice, this does not overlap it completely, so that's not the answer. This does not overlap it, not the answer. Does not overlap it. Whoops, there we go. It's not the answer. However, if we do this, notice they are directly on top of each other. I turn one off, turn one on, and it's the same graph. Okay, so that just confirms the correct answer here is letter D. All right, next up, which of these has the same median as this given data set? So if we look at the given data set and find the median, the easiest way I would do this is just start from the ends, cross everything out until you're left with either 1 or 2 values in the middle. So the median for this is going to be 8. So which of these is going to have a median of 8? Now, you don't actually have to calculate this, because if you look at A, okay, and you start crossing out, well, it's obviously not going to be 8. All the 8s are already gone. Okay, what about B? Cross out. Okay, looks like it could be B because we got 2 8s in the middle here. C, again, if you use the cross-out technique, there are no 8s left. All right, we only have 10s left, so that's wrong. And same thing with D, 8. All the 8s get crossed out. It can't be that one. Okay, so the correct answer for this is going to be letter B. Now, I will just, again, demonstrate something in Desmos that you can use the median function to calculate this. Not necessarily any quicker on this problem, but it's still something good to know just in general. So there's the original. The median of that is 8. And then you could run through the answer choices. I won't bother going through all of them, but you can see for the A, it is not correct. Now for B, It is going to be 6, 6, 8, 8, 10, 10. Okay, so notice we get the same median here. So that just confirms the correct answer is letter B. This is an alternate way you could solve this problem. All right, next up, we have a basic rate problem, or really a proportion problem. So essentially, it's 12 pounds of cherries in 3 minutes. So I put the pounds on top and the minutes on bottom. How many minutes for 96 pounds? So pounds goes on top, X minutes goes on the bottom. Now, when you set this up, if you notice that this is just times 8, 12 times 8, 96, you could use the same technique here, and you could just multiply this by 8, and the answer is going to be letter C, 24. But if you didn't, you could instead just go ahead and cross multiply this and get 12x equals, should be 288, and then just divide by 12. Let's just go to Desmos and confirm that we get the same answer. 3 times 96, and now divide that by 12, and we get 24. Okay, so that just confirms we did, in fact, have the correct answer. Next up, number 7, basic right triangle trigonometry here. What's the value of tan x? Well, we know that tan is equal to opposite over adjacent from SOHCAHTOA. So the side opposite x here is 26. The adjacent side for the angle it's x degrees is 7. So the correct answer for this one is letter C as well, just 26 over 7, and that's it. Next up, question number 8. Here we have a scatter plot on a graph which has a bunch of points on it. Which of the following is closest to the slope of this line? All right, so first of all, notice it has a positive slope because it goes up from left to right. So these are obviously wrong. So now you're down to basically 2 choices. So, I mean, you can basically look at this and just kind of estimate it. And you can see, okay, say it's like right here at 1. All right, and just estimate this as like, 0.5. When I go over here to 2, okay, how much, like, where does it go up to? Okay, it goes up to like maybe, I don't know, 1.1, 1.2, like somewhere in that ballpark roughly. Again, I'm using like the points on the line here. And actually, this one is probably not. Let me just erase that. Yeah, and kind of start over here. So, sorry, using the points on the line, this is probably more, say, like 0.7. And this is like maybe 1.2 approximately. So, notice the change in x, denominator of your slope, is 1. The change in y, how much it goes up by, is like about 0.5. So again, we already know these two are wrong. It's going to be C. It's obviously not going to be D. For D, it would have to go up vertical change over 2 units for a 1 unit change in x. So the correct answer for this one is just going to be C. Now, I will show you that we could just go to Desmos and we could pick 2 points and estimate, and we're going to get whatever's closest. So first of all, it looks like it goes through the 0.42, so let's actually use that one. And let's see, what do we want to use as an estimate? Let's just try to use the y-intercept over here. I'm going to say this goes through like 0.4 approximately. And now I'll do linear regression. Now you could type it in manually, or we can actually just click the button here, linear regression. So notice, using those 2 points, it gets the equation for me. It calculates the slope as 0.4. That's very close to 0.44. It is not close to 2.27. So that just confirms letter C will be the correct answer. All right, next up, question number 9. Here you're given the equation of a line. You're told another line is parallel to this given line. What's the slope of this other line? Well, parallel lines have the same slope. So the answer for this is going to be just the slope of the original line, which is 1/4. So you could type it as 1/4. You could also technically type it in as 0.25. You could also do 0.25. Either of them, either of those answers would be correct. But the slopes are the same, so the answer is just, 1/4, however you want to type it in. Next question asking about a factor of this given expression here. So if you notice here, since there's only one term, it's really just asking for, a GCF, that greatest common factor, can be pulled out of all these terms. So notice, going through some of the answer choices, do they all divide by 2? Yes, they are all even numbers, 2, 38, and 10. Okay, so it's probably going to be that, but let's check B, C, and D. So, do they all terms divide by 5? No. 38 does not divide by 5. 2 does not divide by 5. Also, the last term doesn't have an x in it, so it couldn't be that regardless. Same thing with C. They don't all divide by 38. They don't all have an x. And last thing with D, okay, they do all divide by 2, but again, they don't all have an x squared in them, so that is not a factor of it. 2 is the only thing that you can, expression here you can factor out, to make it basically look like that. So correct answer here is going to be letter A. Next up, question number 11. So here you have a ball. It's dropped from initial height. They give you, bounces off the ground repeatedly, and each time it basically comes up to 85% of its previous height. And they want to model this as an exponential function. Okay? So h of n is the height of the ball after basically how high it bounces up after it hits the ground n times, where n's a whatever number between 1 and 10. All right, so a couple things. First of all, the initial height of the ball when, basically when n is 0, before there are any bounces, is 22 feet. So that is the initial or starting amount. That has to be in the front for the basic form of an exponential function. So these two are out because of that. It has to be 22 times something to the n. And then each time, it's basically 85% of the previous value. That means you're multiplying by 0.85. So the answer is going to be letter B here. A would be the answer choice if it was only, going up 22% of the previous bounce's maximum height. That's where the 0.22 would be. But the correct answer for this one is, like I said, just going to be B, because you're basically taking the 22 feet, and then after one bounce, it's 85% of that, which is just 22 times 0.85. And then after a second bounce, you're going to take that number, and you're going to multiply it by 0.85 again, and so n just here represents, like I said, the number of bounces. So correct answer for this one is letter B. All right, next up, number 12. Here we have a function that you are given, and they want to know, you're given essentially the y value or the output. They want to know what is the x value that corresponds to this. So, in other words, if 5x plus 8 is equal to 58, what is x? Well, you can just solve this equation. Subtract 8, divide by 5. X is equal to 10, so the correct answer for this one is letter A. However, you could also do this in Desmos. And let's just show you how real quick here. Type in the original function. You actually don't need the f of x, but you can do that. Now, I'm just going to graph y equals 58. I have to zoom out a ways. Okay, where do they intersect at? Right here. The x value, which is what we're looking for when y is 58, is 10. That's our answer. That's how you could get this entirely from Desmos. Next up, we have a rectangle. You're told its area. Of course, area of a rectangle, length times width. So its area is 63, and the length is equal to 9. The width is not known. The width is what they want. So if you set up this equation right here, just divide by 9. What does the width have to be? Well, it just has to be 7. Correct answer is going to be letter A. Next up, question 14. Here we have a system of equations. So a couple things. This one's actually not that difficult to do by hand, because notice the second one you can already just solve it for x, do minus 8 minus 8. So x is 3. So y is this equal to 3 squared plus 14 times 3 plus 48. And you could do this on a calculator or punch into Desmos. I believe it's going to be, let's see here, these two add up to 90 and then plus 9. So what is the value of y? It is 99. That's what you're going to type in. However, again, we could do this entire thing in Desmos, and this might be quicker. Graph the two functions 8 equals 11. Then we look for the intersection point. Now, obviously, we're going to have to scroll out a ways. There's the point right here. Okay, this is the solution to this system of equations. What's the value of y? It's 99. That's it. You get the entire thing, again, straight from Desmos. All right, next, here you have a basic formula. First, I'll show you how to do this by hand, and then I'll show you how to do it in Desmos. So if you want to solve this for s, first thing we're going to do is subtract t on both sides. 6r minus t equals 7s. And then just divide by 7. So the whole thing gets divided by 7. So looking at these answer choices, it looks like it is going to be answer choice D, 6r minus t all over 7. Now, let me show you how you could solve this entire thing, and this will solve any formula in Desmos. We're going to type the original formula as a regression statement, okay? So we're going to type exactly what we see, but replace the equal sign with a tilde. Now, notice it's making everything 0. That's not what we want. That's not going to allow any of the answer choices are all going to be the same. So instead, what I'm going to do is I'm going to say, all right, let's set t equal to, just pick a random number, 2.3. All right, now it's still making s equal to 0. I don't want that, so let me just set s equal to 4. And now we have values for r, s, and t, okay? Let me just see if I delete this. Nope, it's still giving me t equals 0, so whatever. We'll go back to 2.3. Okay, now all I got to do is type each answer choice, and I'm looking for the one that matches s, which is 4. Okay, answer choice A is not 4. 7 times. Let's check answer choice B. Is that 4? No. Let's check answer choice C. Is that 4? No. Okay, so it's got to be D by process of elimination. And there it is. It's 4. That just confirms it's the correct answer. So again, I'm looking. These are all equal to s. I'm only typing the right side, and I'm seeing which of these right side expressions is equal to the value for s that, in this case, I had to define, but in most cases, it'll actually determine it for you in the problem. Next up, we have a ratio problem here. So we know that x to y is equal to the ratio of 12 to t. Now, when x is 156, so let me just erase this. What is y in terms of t? Okay, so we're really just solving this for y. So I'm just going to cross multiply, and I would get 156t equals 12y, and then just divide by 12. Y equals, it looks like 13t. So the correct answer for this should be A. Now, an alternate method you could use here would be to pick numbers for the different values and then see what the t, what t has to be, and then plug that in and then see if that's equal to y. Okay, so what I mean by that is this. I would first, let's take this, we're just going to take this proportion right here, right? So I'm just going to let y equal 156. All right? Then, so if I do that, and this is just 156 over itself, this is really 1. What number does t have to be? Well, t just has to be 12, because 12 over 12 is what makes 1. So if y is 156, then t has to be 12. Now I'm going to go through all of the answer choices, and I'm going to plug in just to Desmos the t value and see again which gives me the same value for y. So let's just define t is equal to 12 up here, and then I can just type 13t. Notice, that gives me the 156 for y because it's correct. Does not give me 156. Incorrect. Not 156. Incorrect. Not 156. Incorrect. So this just confirms that A is the correct answer, and this is like an alternate approach you can take. Basically, it's picking numbers. All right, let's look next at number 17. Here you have basically a linear regression problem where they give you this function here, a plus bx. So technically here, b is really your slope, and a is really your y-intercept value, like your starting amount or initial amount. And it says, what is the value of a? Okay, so a here is your y-intercept or your initial or starting amount, i.e. it's what is the, in this case, the f of x or the y, the weight, when x is equal to 0. Okay, well, when x is equal to 0, that would mean it's basically at birth. It's 0 days after it was born. So what was its weight, when it was born, 0 days after birth? Well, it's just 241. That's it. You don't need to do any actual calculations. It's really just like an interpretation, linear function interpretation problem. Okay, next up we have some parallel lines here. And told that y is equal to 2x plus 8. So this right here is 2x plus 8. What is the value of x? So basically what's going on here, parallel lines. So this is 58. There's multiple ways you could look at this. So this angle down here, it's a corresponding angle for two parallel lines cut by a transversal. This will also be 58. And now you can say 2x plus 8 plus 58 equals 180 because these two adjacent angles form a straight line, basically a linear pair. Therefore, by the way, this is a curve. It's still the number 58. They add up to 180 degrees. They're supplementary. So you can go ahead. 2x plus 66 equals 180. 2x equals 14. X equals 7. Therefore, we have, no, it's 7. 2x equals 114. Sorry, 180 minus 66 is 114. This is 57. This is not 7. Correct answer for this one is 57 for the value of x. Okay, next. We have basically an inequality here, which turns out to be x is less than or equal to, because it says at most, it means that like this is the ceiling for x. It can't be higher than it. 17 less than means we're subtracting 17 from 5y. But then it tells you y is 3. So x is really less than or equal to 5 times 3 minus 17. X is less than or equal to 15 minus 17, or negative 2. What is the greatest possible value of x? X can at most be equal to negative 2, and that's your answer. Next up, question 20. We have a basic system of equations. So the way they want you to solve this is to just add them together, because if you do that, notice x plus x is 2x. 3 plus negative 3 cancels out. Negative 2y plus 2y cancels out. 5 plus 7, 12. So what does 2x equal? 2x equals 12. Correct answer is letter C. However, it's honestly not that much longer to just go to Desmos if you want. Type in both equations and find the solution value for x, which is right here, 6. Deleted it, and then just multiply that by 2, and you get 12. So if you want to do it that way in Desmos, again, if you don't recognize, to just add them together as they are to make 2x, totally fine. Correct answer for this one is letter C. All right, question number 21. For what value of x does this function reach its minimum? So because this is a quadratic, and notice it's in vertex form, x minus h squared plus k, the minimum always occurs at the vertex. the vertex for this function is h comma k, which is negative 7 comma 4. So they want the x value. For what value of x? Therefore, the correct answer to this problem is negative 7. However, we could also go to Desmos, graph the function out. Okay, where's the minimum happening? It's right here. So for what value of x does that happen? Negative 7. That's it. That just confirms we have the correct answer. All right, last question here, number 22. So with this problem, basically what's going on is you have this function here that gets translated down 3 units and then to the right 4 units. And they want to know, what's the new function look like after those translations? All right, so first part, if it's going down 3, that just means you're subtracting 3, say like outside any parentheses or away from any x. So the 5 minus 3 here is going to become a 2 at the end. So this is wrong, this is wrong. Now, for the right 4 units, technically if we're going right 4, it means you replace x with x minus 4. So this x on the bottom is going to get changed to x minus 4. Therefore, the correct answer for this problem is going to be letter B. It's this one right here with the minus 4, not the plus 4. Here's how you could also determine or solve this, though, in Desmos. Okay, I'm going to graph the original function. Now I have to add a slider for a, so I'm just going to pick, whatever random number. Let's just pick 10. Okay, so here is the original function. Now what I'm going to do is I'm going to type in the answer choices, and I'm going to see, do they go down and left? Or, excuse me, down and right. So this one looks like it goes down, but notice also it's going to the left. It's not going to the right. In other words, here it's going across, over to here. You know what I'm saying? If you look at the same y value, 13.49, 13.39, like around here, notice it's going to the left, it's not going to the right. If you do now, if I check out answer choice B, notice here you can visually see it looks like it's going down and it looks like it's going right. You can see right here, 64, going to the right side of it. Now, if you want to check C and D, so first of all, here is, okay, so if you look at C, you can clearly see here, it's not going to the right, right? It's going to the left, so this one is wrong. And let's check. So this one, it looks like it goes to the right, but notice it doesn't look like it goes down, especially it doesn't look like it goes down 3 units, because way out here at the edge, notice like it actually, the translated one is actually above the green one here, which is not what we want. We want the translated one to go down 3 units, which means the black should be below the green by 3 units at every single spot. So that just confirms that that one is incorrect, and therefore the correct answer is letter B. All right, so I hope you enjoyed this video going through Module 1 of Bluebook PSAT Practice Test number 1, the grade 10 version, math section. If you did, please do give this video a thumbs up, subscribe to my channel, and sign up for notifications. If you have any questions or comments or alternate solution methods, please feel free to leave them in the comments section below. Also, check out the videos for the 2 second modules, both the easier one, which I call Module 2A, and the harder one, which I refer to as Module 2B, from the same test once they are posted. And lastly, if you're looking to improve your knowledge of Desmos to help ace the PSAT and ultimately the SAT, please check out my Ultimate Desmos Guide to Digital SAT Math. It's over 6 hours of tips and tricks and 65 practice problems to help you use Desmos to ace the digital PSAT and SAT math sections.